Hello team, today's challenge is prime factorization where we're given a number like 20 and we're expected to get the prime factors that multiply up to make that number, that 20. So in our case, it would be 2 and 2 and 5 because 2 times 2 is 4 times 2 is, 2 times 2 is 4 times 5 is 20. And unfortunately, there's no special formula for doing prime factors. We kind of have to muscle our way through. So we would go 20, and then we would find our first prime, which would be 2. And we would go 20 divided by 2. Yeah, that's 10, right? So we'd add 2 to the array, and then we would take 10 and divide it by the next prime, which would be 2, which would be 5. That's right. So then we go 5. Can we divide by 5 by 2? No. By 3, by 4, by 5. By 5, we absolutely can, so we would add 5, right? We kind of have to do this brute force technique. Thankfully, this is not our first time doing primes. Over here, way back in January 9th, we did circular prime, where we came up with this. And this is something that I use on a lot of my prime, any of these challenges that need to rely on primes, where we test if it's greater than 1, because that's very important, right? 0 and 1 are not considered primes, but they are very important to the sequence. So we get those out of the way right there, and then we do this bit of math. And what this does is we go, we start at 2, obviously, right? Starting at 2, that's where this is 1, this is 2, and we immediately do the square root of number. This saves us from having to do the other side. So going back to 20, if I do 20 and then I have that 2, right? 20 divided by 2 is 10. Well, I don't need a 10. I don't need to test if 20 is divisible by 10 because I've already tested for 2, right? So the square root saves us having to do that, which greatly reduces our loop. And then we increment, and this time we returned false, right? To say that it wasn't a prime. Otherwise, we return true to say that, yeah, that absolutely is a prime. Okay. So we're going to use this pretty much this exact same thing. I'm going to copy this over just so that we have it as an example. We aren't actually using it. We'll type it from scratch, but we'll be able to see the differences. Okay. So to start off, instead of returning true or false for this first part, okay, we should just throw an error. That seems like the easiest way. So we're going to go n because it's that way. In fact, I could, if I really wanted to, I could just change this to number to keep things the same, and same stuff, right? So right here, we do that, and then we throw new error and make it something useful like oops. Spell it right. Here we go. Oops. There we go. It should actually be something like num needs to be greater than 1, right? A very useful message. But for today, I think we'll get away with that. And then we drop into our loop. So we go let I equal 2 just the same way. And my fingers don't want to type today, but that's okay. I less than equal to math.square root, just like this, of that number, right? And then, of course, I plus plus. Again, exactly the same. So no magic there. And this really cuts down on the loop. Again, that's the whole goal here. And then, of course, if. So this is where things start to change. So this part is the same, where we go modulo I, right? Num modulo I equal to 0, then we need to do something, okay? What do we need to do? Well, I'm going to drop into a new line just so that we can see it. We need to return whatever I is, and we need to go back in and do it again. But we want to return this as an array, so we go I and prime factorization of this thing. So right here, prime factorization of the number divided by I. So up here it was modulo I. Right here it's divided by I, which we're guaranteed to do because, well, we've already guaranteed that it can cleanly divide, right? The key with this is that we don't want an array of nested arrays. We want this array to be, we want the items in this array to be part of this array. So we should spread those out just like this. Brilliant. And then the last part is, if we get through this loop, then our number is actually prime by itself. Right? So what we should actually do is we should return the number. Okay. At which point it works. We can get rid of this right now. This was just to help us visualize, but this is the code, right? So if we're looking at this, bringing this back just so we have it, very much the same. In fact, if I had to do both of these, I would probably pick this one and then use the nature of this inside of here to test for prime, right? So I would use prime factorization inside of is prime, and if I got something that was if the length was greater than 1, that's the word I'm looking for. So if the returned length of this array was greater than 1, then it is false. Otherwise, it's true, right? You can start to modularize some of this code, right? You can get rid of this one, just using this one, doing the stuff. Great, okay? But here we are today. So this is prime factorization, right? Where, again, if it is less than 1, if it is less than equal to 1, that's not going to work for us. We need to do something else. So we throw an error, right? And then we loop over it. Very efficient loop. We test for that stuff, and we do a little recursion here, which is where the magic is, right? We just keep reducing down the number that is passed in here until we get it all sorted out. And of course, we spread all those numbers back into our primary array, at which point we return, right? That's the whole thing. And it works. It works great. So the question is, what do you think, right? Do you like it? Do you hate it? Did you go a different way, right? Let me know all that stuff. Again, not every solution, just hopefully one good solution. This has been my solution today. I'm very interested in seeing all of yours. So hit me up in those comments. Let me know. Otherwise, this has been Prime Factorization, and I will see you tomorrow.